Alright, welcome back to series parallel circuit faults. In the last video we looked at opens in the series portion of our series parallel, and this time we're going to look at opens in the parallel portion of our series parallel. So for this example we are going to open R2, and you will see right away that the current in branch 1 goes away. Now, because R2 is open, there's no longer a path for current that way, and so our series parallel has actually become a series circuit with only R1 and R3. Now that we see what's going on as far as current flow in our circuit, let's take a look at resistance. So we would expect, just looking at our circuit, that resistance would go up, because originally our parallel circuit portion was 1K and our series resistor was 2K, so we had a total of 3K ohms. And there it is right up there on the circuit. And we know, of course, that that is changing. Now, of course, because R1 and R3 are in series with each other, we just add those together. And we get 2K plus 2K, and that gives us 4K ohms. So we know that total resistance has indeed gone up. This is a perfect example to look at our Ohm's law arrow theory. So if we put that up on there, we know that voltage is staying the same, our incoming voltage, and we know that resistance is going up. So we would expect current to be going down. When we look at what total current is actually doing, we put it up there and we see Ohm's law, voltage divided by resistance. We see it was 4 milliamps, and of course that has changed. Now it is 12 divided by our new higher resistive value of 4K, which gives us a smaller current of 3 milliamps. So current has indeed gone down. Alright, once we have determined total current and total resistance, we start looking at what's happening with our voltage drops. Now, because total current has gone down, we would expect the voltage drop of R1 to also go down. Resistance hasn't changed, current's gone down. We know based on our Ohm's law arrow theory that the voltage drop of R1 should have gone down. So when we take a look at it, we see we had 8 volts, and now we have 2K times 3 milliamps. We have 6 volts, which has indeed gone down. We look at the voltage on R3, and we know that now it is a series resistor, so it has total current. So 2K multiplied by 3 milli gives us also 6 volts. So the voltage out on branch 2 on resistor 3 has gone up. It was 4 volts and now it is 6 volts. And the voltage on R1, our series component, has been driven down by the decrease in total current. Of course, we know that branch 1, where resistor 2 is, and branch 2 share the same lead. So even though R2 is not functioning, it will see the same voltage as R3. We know that both conducting and non-conducting branches in parallel show the same voltage drops, and that is because they share the same leads. And so we have seen that our parallel section of our circuit has increased in voltage, and our series portion of our voltage drops have decreased. Alright, I hope this was a good chance for you to see how you can use the Ohm's law arrow theory to predict voltage drops when you see faults. This is just a small example of an open in a parallel, in a series parallel circuit, and next we're going to look at a short in a series parallel circuit in our series portion.